Hey guys, this is Preston with the DLASC. Continuing with proofs for logarithm rules. This time we're going to go over the product rule real quick. So the first thing that I'm going to do is, just like before, we're going to go ahead and write the relationship between logs and exponents. So if I have log base a of b equal to c, then it is also true that a to the c is equal to b. Okay, so that is your basic relationship between logarithms and exponents. All right, and then also we need to go ahead and note what the product rule is. The product rule states that log base a of b times some other constant, I'm just going to say d, is equal to log base a of b plus log base a of d. And so I'm going to attack this pretty much the exact same way that I did the other one, except we're going to need two separate expressions because this time I have not only log base a of b, I have log base a of d as well. So I'm going to need some constant to represent both of those expressions so that I can break everything down. You will see exactly what I mean in a moment. Let's go ahead and write so that we can keep note. This is the product rule. This is what it says. Okay. All right. I'm going to go ahead and actually put this right up here at the top. Move this down like that. Okay. So I need one more relationship, right? Because we have one for log base a of b. I'm going to go ahead and write one for log base a of d. Okay. So I'm going to do log base a of d is equal to, let's just call it e, because why not? That's the next letter in the alphabet. That makes sense. And we'll do a to the b is equal d, right? That's true. Okay. So again, if this is true, this must be true. If this is true, then this must be true. And that is because exponents and logs invert each other, right? They are the inverse of one another. Okay. So what I'm going to do is, again, I'm going to go ahead and just start with a to the c is equal to b. We're just going to go ahead and start with one of these. Because if you look up here, what I'm trying to prove is that this right here is true. And so what I'm going to do is I'm going to multiply d by b. And if I've got b times d on the right-hand side, if b is equal to a to the c, just like we had done before, I'm going to have to do it to both sides. So this is going to be a to the c times d is equal to b times d. And let's just see what happens, see what we can do. Okay, so first thing that I'm going to notice is that d is equal to a to the e, right? So I'm going to go ahead and substitute that on the left-hand side because it's got the same base as a to the c. And it looks like there's something that I'm going to be able to do with that there. Sure enough, there is. On the previous video, we talked about the exponent rule quickly. The same thing applies here. This is e. So what's going to happen is it's going to be a to the c plus e is equal to b times d. Okay? And then now I have this relationship, right? And the way that logs are related to exponentials, I can use the way that that relationship is laid out and go ahead and say that, well, if this is true, then that means that log base a of b times d must be equal to c plus e. That has to be true. Okay? Now, if that must be true, then it must also be true that log base A of B times D is equal to, notice that C is equal to log base A of B. So I'm going to substitute plus E is equal to log base A of D. And so there we go. Now we have a proof for the product rule of logarithms. And I hope that makes sense to you. I'm going to make one more video for the quotient rule. So stay tuned.